Okay, we're picking up on linear equations, functions, and inequality. Functions. What fun. Okay, so let's take a look. So they gave us a table. If you want to read the words, you can. Typically, the words sometimes get distracting. Far be it for me to tell someone not to read. Although Caesar did say that reading does cause the mind to rust. Ironically enough, he wrote that in a book. But anyway. So, you already know that this is linear functions and equations. So you don't have to test every iteration to make sure that the rate of change is constant. But what you need to do is first you need to identify your x variable and your y variable, or rather your independent and dependent quantity, whether we want to admit it or not. Our x is independent, which means our x is in control. So this is our x, and this is our y. Okay, that being said, we need to identify our change in y and our change in x. Well, our change in x is relatively simple. The difference between 2 and 5 is 3. If we can't do that, we have all sorts of trouble. So change in x is equal to 3. Here we have our change in y. Again, a simple act of subtraction is 81 cents. And so the first thing we need to do is we need to find our slope. Our slope is the change in y divided by the change in x. This, of course, you learned in Algebra 1. Right? So, you've got 81 divided by 3. Now, if you have to use your calculator, you can. But 81 divided by 3 is 27. So, 0.27. That's your slope. Now that you have your slope, you can use one of your points and you can simplify it into point-slope form. Point-slope form, which is on your formula chart, which I'm hoping to have attached as a link in case you don't have one at home. Feel free to print one out. You get to use a formula chart on pretty much every standardized test from now, from now until you take either an independent study or that's about it. Okay, anyway, let's get back to it anyway. Point-slope form. That's the one in your... I taught it to you as y is equal to m times x minus h plus k. You may also see it as written as m times x minus x1 plus y1, but the idea is the same. These two constants were actually given to you in whichever point you want to use. Now, for simplicity's sake, I just say use the first point because the values are lower. And so what you do is you write, alright, y is equal to the slope, which we already know what it is, 0.27, times x that's going to remain unknown, minus the x that we know. Well, in this case, the x to the point that we're going to use is 2. And the y that we know is 206. Now that's hideous. We're going to simplify that down by distribution. And so we're going to say, alright, this is 0.27x minus 0.54. Yes, 27 times 2 is 54. If you don't believe me, use a calculator. When you do it on the test, if you don't believe yourself, use a calculator. Plus 2.06. So essentially we're asking ourselves, what's 206 minus 54? It should be 152. So you have now that the function is now 0.27x, that's your slope, plus 1.52, that's your starting constant, that's your y-intercept. And so here is your slope here is your point in slope-intercept form. Very often on tests we want things in in slope-intercept form because there is only one way that a line can be written in slope-intercept form, whereas point-slope form the combinations are infinite. Now, that being said, we have our function. Now let's look to our two corollary questions. What would the cost of a 45-minute international call be? Basically what they're asking you to do is height. Do you know what you're looking at? 45 minutes. Does that make it an x value or a y value? It makes it an x value. So basically they're saying, hi, now solve it if x is equal to 45. So you're like, alright, well I already know that this is 0.27x plus 1.52. But instead of x, I'm going to put 45. Now after that, it's just a matter of arithmetic, and you'll have a calculator at your disposal, so I have no shame in using one of my own. So, you have now 0.27 times 45 plus 1.52. And final solution should be 13.67. And that would actually be in dollars. And so that was fun. Now, the second one might be a little bit less fun just because they gave you a dollar amount, but actually it's not that hard. So in this case, first one they gave you the x, second one they gave you the, anybody want to guess? You guessed it, the y value. Okay, so now we take the same equation, we say, okay, y is equal to 0.27x plus 1.52, and we say, okay, 20.96 is equal to 0.27x plus 1.52. Now, this is basically, except for the fact that you're dealing with decimals, a very simple Algebra 1 problem. So, you subtract 1.52 from both sides, and then you divide the whole thing by 0.27, which you can do with relative ease, again, on the machine. Because at this point in the game, I'm not trying to teach you arithmetic skills. If you don't know arithmetic by now, we're really screwed. So, we just say, okay, 20.96, okay, minus 1.52, got it. Now we divide by 0.27, which was the coefficient of x, and so x is equal to 72 minutes. And there we go. That was fun. Okay, now let's go on to the next one, shall we? Going once, going twice. Right. Okay, for this, it's height. Do you know how to graph? Now, hopefully we know how to graph, considering you first learned how to graph your freshman year. And for some of you, possibly even your 8th grade year. So it's height. What's my slope? What's my y-intercept? My intercept, of course, is 2, so we go up 1, 2. And my slope is negative 1/3, so I go down 1 and over 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. You may want to iterate points because some of you are actually not that careful with straight edges, and actually I'm pretty clumsy with a straight edge myself. Up 1, over 1, 2, 3. Okay. So we take our handy dandy straight edge, and we draw ourselves a line, and the line is solid because y is actually equal to that value. And we put our little arrowheads because it keeps on going, not because we're going to shoot people. Okay. Yes, we are not shooting people with infinite lines over infinite space. Not a good way to hurt people. Yes, hurting people with math. We have ways of doing that. Anyway. So that was fun. Okay, second one, equally simple. So you go down to negative 4, that's your intercept. And, wait, there's no denominator. What do we do? Oh, wait, we remembered something. There's always a denominator, even if I don't see it. The denominator that I do not see is 1. So we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And so weiter till you get to the end. Again, it's a line. So we connect the dots, voila. And we put little arrowheads, and there we go. Now this one is fun. There is no x. And some of you are like, oh my god, there's no x. Some of you would be absolutely lost without your x. It's really kind of sad. Here you thought you were the independent one in the relationship. How sad. Well, in this case, you have that y is equal to negative 4. Well, let's go to where y is equal to negative 4. Well, y is equal to negative 4 right here. Do you want to know where else y is equal to negative 4? Here, and here, and here, and here, and frankly, quite a few places y is equal to negative 4. And so, whenever you have a y by itself, you have a constant function, which is to say, you have a horizontal line. So that was fun. Now we have inequalities. This is actually kind of fun. So inequality, you have y is equal to negative 1/2 of x plus 4. Okay, y is greater than. We'll get to the greater than in a moment. First of all, we look at this thing and we realize, wait, our function is not defined at that point. So, this tells us immediately we have dotted lines. So, we're going to graph our line, but we're going to use dotted lines first, and then we'll figure out how we're going to shade this bad boy. Okay. So, we're going to start at positive 4, and we know we are going down 1 and over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Up 1 over 2, up 1, 2 to the left, up 1, 2 to the left, and so on. Handy-dandy straight edge, but instead of drawing a straight line, we're going to make a dotted line. Very fun. Okay, something like that. Still making arrowheads because it goes on forever. Now, this is the part where you have to think. Y is greater than. We know y is greater than because it looks like my right hand. See? This looks like the little inequality symbol, yes? Now, greater than, and you're talking about y. Now, since y is talking about up and down, and I'm talking about greater than, I shade above. Well, that was fun. Now, hang on. Okay. This one is that y is less than or equal to. The reason I know it's less than is because it looks like my left hand. So, we start at 2. We go up 2 over 1, up 2 over 1, and so on. It's a solid line because we got a line underneath the equal sign. Function's defined at the line. So we've got enough points that we can actually sketch this thing, make it look good. And because it's less than, we shade below. Okay, now for the last one. The last one is a little bit on the fun side. So, let's see what we got here. Okay. So, for the last one, we've got our x by itself, which we always thought that that would be a good thing, except some of you find that somewhat confusing because it's not like anything you've dealt with before. Well, if you look at your previous example, when we've got y by itself, it's a horizontal line. If you have x by itself, it is a vertical line. Now, so we strike a dotted vertical line at 2, because there's no bar here as there is here. Now, since x is left and right, and this is x is less than, because it looks like my left hand, we send it Sorry, I totally had to do that just to mess with y'all. Come on, you're watching a math video in the middle of the night. I had to seriously mess with y'all. Okay. And no, I did not write the problem just for the song. Although, I wouldn't put it past me to do it, but I didn't write this particular review. So that was fun. Okay. Quick aside before we get to the practice problems here, and then we'll stop and before we go into systems. Okay. Very easy way to tell the difference between greater than and less than. Let me zoom that out for a sec. Okay, so these are my left and my right hands. This is my left hand. You notice if you don't know your left from your right, you're probably going to be very screwed. So hopefully you've learned it by now. You're in high school and you're about to graduate and go out into the world. You should know your left from your right. My left hand makes an L between the index finger and the thumb. Now, if I look at the same L, it looks like the less than sign. So, left hand, less than. Okay. If I do my right hand, and I'm not very good at drawing with my right hand, so this is going to look horrible. There we go. My right hand looks like greater than. Now, it doesn't exactly rhyme the way left hand less than does, but, you know, if you can remember left hand less than, you've only got two hands, and if you have a third hand, there's something wrong with you. So, this should be sufficient for you to remember the difference between less than and greater than just by looking at it. Okay, so, back to the practice problem. Okay. Two rowing companies on Lake Austin charge different amounts to rent their equipment. The rowing dock charges a rental fee of $5 and then $12 per hour to rent a kayak. I've often wondered where the word kayak comes from. Have to look it up. Austin Paddle Sports charges rental fee of $9 and $10 per hour to rent a kayak. For what numbers is cost to rent the kayak the same? Okay, so basically you've got your y1 is equal to, now let's think about this for a moment. You've got 5 and then 12. One of them is going to be a constant, and then the other one is going to be a coefficient. Give me a second. One more. There we go. Okay. One of them is going to be a constant, one of them is going to be a coefficient. The way I know which one is the coefficient is because I have the term per hour. Anytime I see per, that tells me coefficient. So immediately I just said, ah, yes, 12x. X is now in control. Okay, so we have 12x plus 5. Now, if you think about it, you're only getting charged the rental fee once. It's a constant. It only happens once. Same basic idea. $9 constant, $10 per hour, so y2 is equal to 10x plus 9. And it says for what number of hours does it cost the same to rent for the both of them? Well, you just set them equal to each other and solve for x. Now, you could do it graphically. I don't want to. So y2 is equal to y1, because y is the cost. So you say, all right, 12x plus 5 is equal to 10x plus 9. Subtract 5 from both sides. You have 12x is equal to 10x plus 4. Subtract 10x from both sides. 2x is equal to 4, and x is equal to 1. They did not ask for how much the particular cost was. It only suffices that they are the same. Oh, x is equal to 2, not 1. There we go. So, that was fun. Alright, next one. Find all numbers such that 18 plus 4 times the number is no more than 450. Basically, you only needed to set up the inequality. You don't actually need to solve it because the actual set of numbers is infinite. So, 18 plus 4 times the number, we can say it's n, we can say it's x, I don't care, is no more than, no more, which is to say not greater. It could be equal to. Could be equal to, could be less than. And so really what this was asking you to do is, hi, can you translate words into an algebraic function with an inequality? That was fun. Okay, so up next we get to solve systems. Of course, in Soviet Russia, system solves you.